Cool. Thank you very much. Hopefully you can all hear us okay. So we're here live. So I'm James from Podtex, head of digital manufacturing, and I'll be kind of managing the admin side of the session today. We have the awesome Sofian from the Podtex team as well. And if you joined us today, hopefully you've joined us to learn some more about facades and digital, basically methods of how to install it. And yeah, Sofian's prepped a lovely presentation where he's built a nice NDA-free demo from some old client projects that we've worked on to try and disseminate some of those value points and interesting things over to you all. So yeah, I'll hand over to you, Sofian.
Thank you very much, James, for the nice intro. So yeah, my name is
Cool.
Sufyan Sayhi. I'm a digital manufacturing engineer here at Protex. In today's session, I will show how a facade installer can use the power of Delmia to plan the installation process from site layout of equipment all the way to work instructions.
Sorry, I may need to add you. It's my first duty as prepping. I'll add your screen share. Is that the right screen there as well?
Yeah.
Is that the one with the notes? You might need to flip, I think, the screen, so we can see that one. If you flip presenter.
Oh, sorry.
It's okay. There we go. Perfect.
Is that better?
Yes. Thank you. Now we'll start. Sorry.
Sorry about that, guys.
Now you know it's live.
Yeah.
That's just to prove it's
live. So before we dive into the webinar, for those who don't know us, we are Protex. We're based in Northern Europe and we specialize in construction, infrastructure, aerospace and automotive manufacturing. Our prime focus is Delmia Digital Manufacturing. We are a licensed provider, trainer and expert consultancy. You've got a flavor of what we do hopefully today. So we also work in robotics and tooling design. So this gives us first-hand manufacturing experience and it helps us understand your manufacturing needs. During this webinar series, we'll be looking at different topics. So various on-site and off-site activities. The series will range from factory optimization all the way to on-site ergonomic assessment. And I'm just going to mention that there's a digital construction week in London. It's next week, Thursday the 6th, and we hope to see some of you there. My colleague James and Ricky will be there. Okay, so I'm going to start by covering some key site requirements here from an installer point of view. We'll look at equipment reach, manpower, handling, rigging requirements, etc. I will then look at the assembly sequence and the connection detail before I can cover health and safety and ergonomics, and at the back of that, work instructions. So what does Delmia allow us to do? Delmia digital tools allow us to visualize all aspects of installation down to the bolt and nut detail. So we can quickly assess different options, determine the most effective way to carry out the work. We can also assess different or various risks that might be associated with a specific task or installation. What we're looking for in the end is a robust installation plan. So the result is going to be an installation plan which has saved us time and cost and ultimately give us the confidence that all potential risks surrounding the project would have been mitigated prior to us starting the work. Great. So for those of you who don't know 3D Experience, it is a software which brings together all form of CAD data, reports, Excel sheets, automation, logistics into a single platform. 3DX is about bringing people from across the business together. They'll be all using the same interface, whether they are managers, engineers, designers, sales executives, manufacturing engineers, etc., etc. 3DX provides a catalog of applications to enable the users to design, inform, collaborate, and simulate. So the backbone of the platform has always been connecting the latest data easily to the right people. So 3DX has been in development since 2012 by Dassault System, and it's widely used across different sectors now. So back to the facade installer, created a little digital roadmap here. So always start with the EBOM. I know we're installers, we're not manufacturers, but we can still use an EBOM, an engineering bill of material, translate that into a manufacturing bill of material, and then make a process plan out of that. Once we have a process plan, we can start adding our resources to the site. We can do resource allocation, but also workers as well. So at this stage, when we've reached here, I would say that we've got a digital twin. Once we have our digital twin in place, we can conduct all sorts of simulations. Once we've linked our process plan to the site and enrich it with worker and equipment, we can start doing equipment simulations, reach studies, worker ergonomics, and ultimately provide the site work instructions we'll be using when we start the work. So here I have a mock-up of the building. It's a pretty simple, straightforward building, square or rectangular if you like. I've got the facade panels and then joining columns or trunking if you want to call it that. I created the manufacturing bill of materials from the CAD data I have, and then I went to create my process plan from that. I grouped the process plan by floor, which just seemed logical at the time. So I can now just click play and visualize the assembly sequence. Here I started at the top floor, working my way right to left, and moving down to the lower floors. So just by doing the process, I can already see the build sequence or the installation sequence at a very high level. I can make adjustments as I feel. Great, now that I have my basic high-level sequence in place, I'm gonna start enriching my site. So we have access to various libraries where we have imported and previously stored models of equipment. Some of the equipment we use is parametric, so we can easily change dimensions. We can change the tower height, we can change the jib length. So we can, so they suit a specific project. So in this example, we are using a tower crane, 2 scissor lifts there for the rigging team, articulated boom for the other rigger, 2 interior install crew, and the scissor lift in the interior. For transporting the facade panels, we've got a fixture on the truck bed there to secure the facades, prevent any damage during transit. Anything I missed? I think it's everything for now.
Yeah, I think it's worth noting while you play this as well. The a lot of the tools and equipment, obviously there's a lot of standard suppliers out there in the industry. So some of you may recognize, for example, in this simulation, we're actually using Genie's articulated booms and scissor lifts that
Correct.
Sofian's directly imported from their online catalog that's open source. And then Sofian's added what we call kinematics, but basically the movement or the limits of that boom or lift to create cool simulations like this, to save some modeling work, basically. Yeah.
Oh, 100%, 100%. It's gonna start this
Sorry.
again. No, it's okay. Yeah, so the site is now populated with the equipment we need. I can start determining positions. Now, in this case, I'm manipulating the crane there to find the optimum position with regards to the horizontal travel and also the operator line of sight. Then when we get to lifting the panels from the fixture on the truck bed, so that is based on the ground team scissor lifts. Ideally, I want them to stay on the same side of the truck during the whole lifting operation. My goal here is to minimize movement around the site, and when movement is necessary, I'll try to contain it in one predetermined zone. So I'm gonna look a bit into more detail at the installation itself. How is the facade panel going to be connected to the building? How easy or difficult it is going to be to align the panel to these fixing points, and how easy it is for the workers to access those points, really. So if I play this, if I look at the panel approaching, it's going to be quite challenging and time consuming, if anything, to align those holes. We don't have much tolerance to play with. I think they're the same size on the bracket and yeah. So I can communicate this to the manufacturer very easily. I've got one of my favorite tools is 3D markup. Can be used on a web browser. So I can add a note there, request, for alignment aid feature to be added by the manufacturer. Makes it easy for the install there. So we've been working for this manufacturer to develop various design solutions. We've adopted this bracket and we're planning to use it over and over and over again on different size facades across multiple sites. So we don't use a bespoke solution for every site. By the end of this exercise, we will hopefully have in place a plan that can be used over and over across multiple sites without us having to start from scratch every single time.
And if you're not a wizard like Sofian and you can spot some alignment issues ahead of time as well, when this thing gets really installed for real, and inevitably, like Sofian's alluded to, you would find alignment issues because it's so tight to get that tolerance. You could flag that as an issue in the simulation to say we found this in real life. Here is a problem, and then you could retrospectively make sure those are logged against the product to go back and say there was a problem with the process, the holes were all too tight, we need an alignment pin, or we need slotted holes, or whatever your engineering solution is. So it's all importantly tracked and constantly improving our products,
100%.
basically. So yeah, it's really great.
Great. I'm gonna look into more detail now. I'm going to look at the operation. I'm going to start including the equipment and the workers now. Right, so my sequence is going to look something like this. The crane hook is going to be lowered close to the lifting strap. The scissor lifts are going to go up to rigging location, securing the straps to the facade, and then securing the hook to the strap. The lifting will happen. The articulating boom is going to come close, and finally we're going to guide the panel to the location. Whilst doing that, then I realized that those straps might be subject to friction when we are lifting. Again, going back to my same 3D markup document, I asked the manufacturer to increase that cutout. So in the same fashion now, I'm gonna start looking at workers and reach. Can they actually reach all of those positions there? So I have 5 facade panels on that bed track. That's the first one there. Can they easily tighten the strap around the anchor bolt, if you like? Can the articulated boom operator reach and easily guide the panel? Or would they need maybe a rigging rope? We can think about wind there.
Yep.
Yep. And finally, can the install crew inside comfortably reach all of the bolts? And can they secure the panel to the built-in brackets in the most efficient way?
And again, this is really a great thing with seeing this all in 3D is we've often had with different customers where they've brought us in on a real job, which is very similar to this, and they've communicated to us our process is X, Y, and Z, and then we've simulated it, and everyone in the room, 5 people are like these expert facade installers all working for the same company have said, yeah, that's what we mean. And then we've simulated it, and 2 of the people in the room have gone, yes, that's exactly what we meant. And the other 3 have all gone, hang on, that's not what we meant. So this thing of communicating through 3D, it really is like seeing is believing. And all the people in the room are not just saying the same words, but you're seeing the same thing. And it's very hard to misinterpret a 3D simulation. So suddenly you can make sure everyone's on the same page. You've not missed any steps. Everyone agrees that this thing is possible and safe. And yeah, it's really is a powerful tool, I think, for communication.
Absolutely. Well, a picture is worth 1,000 words. In our case, a video is worth probably 1 million words. And when we get to VR, it's just worthless. Great. Talking about VR, it is my favorite tool. So it's the power of Dalmia, all what we've seen combined with a VR headset. I mean, I'm not a gamer, but I really love this tool. I'll spend half my day in the office just playing around with it. Similarly to what we were saying, the difference between a video, an image, or
Yes.
a engineering drawing, that's the difference between using VR to do a check versus looking at a simulation.
Yeah.
On
It's
a
that
screen.
one-to-one scale, isn't it? That, yeah.
100%. So what we can do? Those are some of the few things. Can do ergonomic simulations, VR safety walkthroughs, worker training check, which we have done in the past, etc., etc. So here on this video, I used what we call human incarnation. And it's just striking how accurate the movement of that mannequin compared to mine. So this is a simple installation we're dealing with here, straightforward, but this can be really crucial when we're working on a complex project. We've recently worked on a facade installation for a client of ours where the VR check really proved to be a game changer.
Yeah, and we with that we did all of the cool simulation that Sofian has shown here. So we already, like myself and Sofian, had already realised there was going to be problems on that job, right? We knew that we're not sure if they can reach some of these pins and bolts and holes, and
Correct.
and we did this. Sofian did this same VR check, which by the way is basically once you've set it up, just effectively a button. You click, it's not an external software. You just click into it and it put a headset on. So we'd already checked it and knew there was going to be problems. And it's actually one of my favorite site visits we've done. So we went to the client site where the actual building was being built. And we were there about a year ahead of when this facade was being installed. We had the safety team from the company and one of their workers who was the person who was literally going to install the facade in like a year's time come in. And he said, why am I here? Am I starting this job next week? And we said, no, you're going to do it in about a year. And he was kind of like, why am I here then? Like, just give me the drawings, give me the sheet of paper, and a week before, and I'll figure it out. And we were like, well, just trust us, just try this out. So we put on the VR headset. He did this thing, and we said to him, so your job is you're going to be in this basket 60 meters up in the air, and you need to reach and install those bolts. And he was trying to do it in the VR, and he like was stopping because in the VR he was hitting a plate onto his chest, and he was having to reach and hit this plate at the same time as reaching back and control the articulated boom. And everyone in the room, all the safety people watching him, knew this was impossible, looking at him trying to do it. And then he himself said as well, I can't do this. You need to adjust the plate. I can't reach the bolt, and I can't control that at the same time. I need a second person with me in the basket. And that very small thing had a lot of takeaways. One was with that particular client, the baskets were rated at 100 kilos,
The weight
which
limit,
meant we had to change the articulated booms to take 2 people. And that one mistake alone was estimated it could have cost something like 250 to 300,000 pounds. That mistake of ordering the wrong booms, and that's not to include the fact that we also had to redesign, or like through this they realized they had to redesign the mounting brackets, they had to redesign the release mechanisms, so that excludes all of that saved risk. So these really are it's not like you're alluding to, a lot of people think all this stuff is sometimes gaming things, but it really does have a huge engineering value in that you see it sooner and you can de-risk it, and
absolutely.
save money by getting it right first time.
yeah, 100%. Great. Talking about safety, you might have noticed that something very basic but very important was missing here, which are the safety barriers. We want our digital twin to be an identical twin, really. That will help us mitigate, 99.9% of the risks. Again, I go back to my trusty 3D markup and just put a note there. There should be safety barriers there. Add any other details, anything I'm not sure about. And this document can be shared with everyone in the business or people from outside the organization as well, if they've given access. Again, this is on a web browser. So from there, we're moving on to ergonomics. So ruler rapid upper limb assessment plays a crucial role in safeguarding workers' health and well-being. We can easily assess, tasks that might lead to fatigue or discomfort. And at the end, we all want to ensure safe working environments on site and inside factories for all workers. How can we do this? In a matter of a few clicks, what I can do there is I can perform a reach and grasp task. I can manipulate a mannequin and very quickly generate a comprehensive ruler analysis report, which scores on different parts of the body. So got neck, upper arm, forearm, etc., etc. We saw earlier what those numbers and those colors mean. So remember here, this task will be repeated every time the installer tightens the lower bolt. 4 bolts times 2 on each panel times 5 times 8. So in our case, this is going to happen 576 times by the time we've installed the last facade. Just something to bear in mind.
It's a lot, isn't it? A lot to potentially optimize.
Absolutely. Yeah. The back of that then can create work instructions, that are directly linked to each step of the process. So 2D and 3D work instructions. We can do standard ops, sign off documents and alerts, VR training. Again, seeing is believing. This is very simple. I can create text instructions and images like you would traditionally do when creating a paperwork instruction. But since these are linked directly to the process steps, I can easily create 3D views like I was doing on the 3D markup. So I can enrich them with part numbers, list of tools, PPE, etc. So the result at the end is a web browser document that can be accessed from any device on site. It can also be printed, but ideally you want to have it on a web browser somewhere.
The nice thing is as well with these work instructions is so we've used these for quite a few sites now, and because you've analyzed stuff in such detail, it means your instructions to the crews on site has that detail as well of we recommend this torque wrench, these hoists, you're going to store your tools here because then your walking distance is low back and forth to your tool storage. It really does provide a hell of a lot of detail to
Absolutely.
right first time with the crews.
Oh,
So
absolutely. As you say, I think if you do keep or leave your work instructions till
yeah,
last once you've done all of these simulations, because you can create them directly after the process, but
yes,
you won't have learned a big deal from the simulations yet.
yeah,
So yeah, great.
exactly. It's almost like receiving for me, it's like going from a 2D drawing where they would receive that and say install that to actually use this torque wrench, angle it in this way. It really is that awesome resource enrichment into it is magic. And it's worth saying as well, if you we published, say Sofian published these work instructions to this site, and we got 2 or 3 panels in and realized actually we needed to adjust the tool or adjust the method slightly. Sofian could go in, take everything he's shown you today and put it into version B, and then just republish those work instructions, make the changes and republish the work instructions. So we've also captured the full life cycle as well, which is there's the rework is quick if it needs to happen. Basically, that's what I'm trying to,
Totally.
I guess, add.
Totally. Yes. Yeah.
So
And
yeah,
hopefully, yeah, we've learned now from this one and we'll repeat it,
yeah,
across
exactly,
multiple sites with
exactly,
just a few tweaks.
exactly.
So yes, that was our installation plan, and that's
Mm.
it from me today.
Well, yeah, thank you very much, Sophie. That was really interesting. I hope everyone listening in enjoyed that as well. If you really enjoyed it, and I guess you want to hear my voice again, which I imagine isn't many. I'm also giving a talk with a colleague called Arthur Montilla, who's from Dassault Systems at Digital Construction Week at Excel in London. That is next Thursday, 6th of June, I believe, and it's really a deep dive and just a pure focus on that worker safety element. So we'll be looking at on-site, off-site, a bit of physics stuff, and some other. And watch this space because we've also got some other webinars lined up. And then if you really liked this stuff and you're thinking, actually, this could bring me a lot of benefit, doing some of this facade simulation or construction simulation in general. We do have a promotion at the minute, which is you can try the software for 3 months for just £500. And there's no commitment required, basically because we know once you start, you're going to love it and you're going to find a lot of value. So if that's of interest, please do get in touch. And this is basically because us as Protex, we are official resellers and partners with Dassault Systems. So we sell the software of everything Sofian's just shown you in this webinar. We also actually consider ourselves expert consultants within Delmia, which is the manufacturing construction side, I guess, of the platform and the toolset. So what does this mean? It means we can not only sell you the software, but we can offer you training and shadowing and help you upskill all of your teams so they can become an expert and do all this stuff that we've shown you and push the boundaries. And we also like to point it out because we are a team of industrial people as well. We are doing this for real customers all of the time, working on real facade projects or healthcare projects or commercial, etc. So you can also phone us up for advice on how you think technically project should go. And we can obviously help you with your workflows and things as well. So that about rounds off the webinar. So if there's any questions, we have we're bang on time, which is a shocker. A shocker. 30 minutes exactly, almost. So if anyone has any questions, we can maybe, if you wanted to comment them on LinkedIn, I think it should come up for us. And if not, we can also feel free to comment if you're watching this replay back, and we can try and reply to you on LinkedIn as soon as possible. Or obviously, as well, you can always contact us via the information on screen right now as well, or just through our LinkedIn page. So I don't think we have any questions popping up just yet. Give it a minute. I'll just check on LinkedIn as well. Just checking in two places, apologies. Yeah, I think silence is golden. It must have been super clear, Sofian. Yeah, as I say, if anyone has any questions who's watching this back, just please get in touch. And yeah, thank you again, Sofian, for the great presentation. It was really, really interesting. I hope you all enjoyed it as well.
Thank you very much.
Cool. Well, thank you all, and we'll end it there. Thank you.